Good morning, everybody. We're Team 2 from Group 120, and today we're going to present you our STEM 2025 PIA presentation. Now we're going to introduce ourselves.
My name is Romina Rena Flores.
My name is Natalia Carmen Acosta Contreras.
My name is Lucero Estefania Garcia Cárdenas. My name is Natalia Cárdenas.
And my name is Aranza Monserrat Romero.
Here we have a table of content with the topics that we will review in this presentation. First, we will start with a general introduction about our STEM project, leading up to a research question and why we decided to do this question, to ask ourselves this question. Next, the SDG of our project. It is the SDG that our project seeks to reach, our general and specific objectives, the justification of why we decided to do this project, our theoretical framework, our hypotheses and variables of our investigation, the methods we use to collect data following the results of the method we use, the 3D design of our prototype, our individual conclusions, our discussion, and finally, how the learning units of DAT and ICT helped us to elaborate our project. For our introduction, we'd like to tell you that our STEM project is mainly focused on the making of intelligent bus stops, which include features such as screens with real-time location of the buses, hour and day, and weather forecast and other information. And it also includes solar panels to get energy from. All of this is to what we want to achieve with this is the increase of the reliability, effectivity, and convenience of intelligent bus stops, so that we can encourage more people to use them. Research question. After studying our problem, which is the waiting time perception and the insecurity in bus stops, we came up with the next question. How can the implementation of smart bus stops change the waiting time perception and experience of people that ride the bus? The selection of this regional question was the popular that helped us to start planning our research and later have a hypothesis and then an experiment. So our STEM project is involved with the SDG 11, Sustainable Cities and Communities. So with our STEM project, we expect public transport to be promoted. Therefore, traffic congestion and air pollution to be reduced. And for the development of the project, we established two objectives, a general one and two specific ones. So the general one is to improve the overall experience of the usage of the bus, and the more specific ones are to create a system of interconnected bus stops and make a bus stop more comfortable environment.
But you might be wondering, why even research this topic? Well, as many of you might know, traffic is a really present problem in Montreal that affects us all. Just think about how much time you make from there to your house. However, we think that there is one great alternative to reduce this congestion, which is public transportation. However, there is one main problem with this, that is the waiting time and the overall experiences in the bus stops. In addition, according to studies conducted by the UN Habitat, on average, one would make twice the time in public transportation when compared to particulars. In addition, there are more studies that show that from 2023 to 2025, the waiting time rise from 30%, in average of 31 minutes. Now our theoretical framework. As I stated before, our problem is the conditions of the public transportation. We think that with this project, we can help solve this problem. Just think about the last time you saw a bus stop and how crowded it was. There are some solutions that already exist to help with this problem, like increasing the bus speed, making buses and bus stops more accessible, having the bus stop schedule, and maintaining the buses in good condition. However, we still developed another solution that we think is the best to help with this problem. That is, to make a system of intelligent network bus stops to make public transportation a more convenient and comfortable place. Hypotheses and definitions of the variables in our investigation. Our hypothesis is that intelligent bus stops will make riders' experiences more enjoyable thanks to its many functions, like the real-time information about interconnected buses, causing the increase of the amount of public transportation users, helping reduce city problems such as air pollution and traffic congestion. In our investigation, we have two types of variables, the independent and independent variables.
Independent variable is the overall system of bus stops, which is a qualitative variable since it is something observable. Our dependent variable is the waiting time or the waiting time perception, which is a quantitative variable since it is something measured that has already been started with the mathematical operations and that can change depending on the condition of the bus stops.
So for the methods we use to collect data, we can rely on experimentations because of the complexity of our proposal. But we decided that surveys would be the most useful tool. That way we could know the opinion of people about our proposal and how helpful it would actually be. The survey was applied to students to test their opinion on our experiment, on our projects. And the results are in these graphs. As you can see, some of these, and the most important ones that we believe are important and relevant to our project include this question. We got 66 answers. And the question was, do you think our city's public transportation is sufficient and in good conditions? The results that we can see are that many people do not think they are optimal for usage or wouldn't rely on them because of their conditions. The next question is, do you think that adding intelligent factors to a bus stop, such as real-time locator of the bus, the weather forecast displayed on a screen, and the routes that the bus takes would make it more helpful? The way it relates to the last question is that also the majority of people believe that adding these factors to a bus stop would make it more efficient and helpful. Finally, would you use the public transportation of our city more often if it had these intelligent factors? And some people said yes, and the second biggest part said that maybe. So this proves that our hypothesis would be correct, stating that the majority of people and students that this survey was applied on would be positively affected by our prototype and our proposal.
So here we have the 3D design of our prototype. To create the 3D design of our prototype, we use the Tinkercad software, which helps us do it in an easy and efficient way. For the construction of the design, we used as a model the design that we had already made in the previous stage, taking into account its measurements to make this new design to scale. And we mainly use the basic shapes section from Tinkercad because our prototype is mainly constructed by rectangles and holes. However, we found the solar panel in the electronics section and the trees in the scenery and structure section. The main tools we used were the bundle and union group found in the object toolbar, the shapes area, the duplicate button found in the paste toolbar, the overall coloring of the shapes we used, and the view toolbar to confirm that our prototype was turning out just how we wanted it to be. So overall, we have concluded that this STEM project has helped us learn how to the process of solving social problems, such as traffic in our case, and how to apply our previous and new knowledge in the development of new technologies that can help us bring the best solution. Also, we believe that our project will help improve the quality of the public system and also encourage more people to use them, reducing the amount of automobile use and helping reduce the air pollution. So finally, for the learning units that we saw at Rethink, the question was, for the problem raised, can robotics be applied as an area of improvement? We answered that robotics wouldn't be that helpful in our proposal since we believe it's more of a digital thing instead of a physical appliance. For this project, a really important the moment of algebraic thinking learning unit, the questions were, did your mathematical results help confirm or reject your hypothesis? In this case, the mathematical results were the graphs, the results we got from the survey, and they helped confirm it since most of the students gave a positive review or an answer to our prototype, and that's what we expected. And what would be your conclusion about the mathematical results that contributed to confirm or reject your hypothesis? We believe that surveys are very helpful and they helped us to collect accurate data. That's what we really wanted. It helped you collect
facts, numerical data, opinions, and overall you can draw a conclusion from that. Finally, this is the bibliography that we use. Most of these were translated by us for the sake of the project. And that would be all from our part. We hope you enjoy it.